Alright, in this video I'm going to go over the AP Computer Science A free response questions for 2026. So these just came out around, I'd say, 2 hours ago. So we're going to go through them and I'm going to show you my solutions to them, how to walk through them, and perhaps what you should have done on the AP exam. Okay, so let's get to it. So as usual, or I should say, this is the first year where the exam is slightly different. I believe the multiple choice section has 2 more questions. There are only 4 answers per question rather than 5. This is also the first year where there's no inheritance in APCSA, which was replaced, or not replaced, but substituted, I guess, with file I/O and exceptions. But you are not expected to write file I/O on the AP free response questions. Okay, so let's get to it. Alright, so question number 1. This question involves the account class, which is used to represent user accounts for a website. The account class contains a helper method is available, which determines whether a given username is available. You will write a constructor and a method for the account class. So as we see here, we have a private string username, which will be created in the constructor somehow. We'll read through how to do that. There's a helper method here, which we will probably need to use at some point. And there's also this method, getShortenedName, which we will write in part B. Okay. So part A, you will write the constructor for the account class, which creates a username based on the parameter requested name. The helper method has been provided to determine whether a username is available. It returns true if it's available and false otherwise. Pretty straightforward. And if it's an available username, then the account constructor will assign it to the instance variable. If it's not, then it will try different variations of requested name until one is found and assign it to the instance variable username. Okay. So the way it works is that it will assign increasingly positive integers to the end of the requested name until it finds one that's available. So for example, if Luis-Cruz is not available, then it will try 1, 2, 3, and so on until the name is available. But if the name's available immediately, then it will just use that one from the start. Okay. Part B, you will write the getShortenedName method, which will remove all hyphens and the character immediately before the hyphen. So if there are no hyphens, then just the username itself is returned. Okay. So for example, with Amy-Marie-Lin, it will return AMMARILIN because it removes the Y in the hyphen, and the E in the hyphen. Okay. Alright, so and then another example here is if there are no hyphens, then it will just return the original name. Okay. So let's write the constructor. So it says you must use is available to receive full credit. And the way I've done this is I just have an IntelliJ project. And let me make this slightly bigger just so everyone can see it. Very good. So this is just an IntelliJ project. It's not quite the environment that you have set up for you in the FRQs, but that's okay. So yeah, let's write the constructor. So the way that I would think about doing this is, well, we first need to, we're going to have some type of loop, right? We're going to have some type of indefinite loop that checks the requested name until it's available. So while it's not available, then we should keep appending those successive integers to the requested name until it becomes available. Okay? But the thing is, we need to keep a copy of the requested name. We can't just do requested name equals requested name plus some counter, because then that will reset, or that rather, it won't reset the requested name back to the original, right? So what we can do is we'll have a variable, we'll just call it name, we'll set it equal to requested name, we'll have a counter, we'll set it equal to 1, and then while it's not the case that the name is available, then we're just going to say name is equal to requested name plus counter, and then counter plus plus. And you can do counter plus equals 1. It doesn't really matter. But note that you have to use the equals here. You cannot use plus equals because that would be concatenation plus assignment rather than just assignment, which is what we want. We want to clear out the original value of name and set it to be the requested name plus the next counter if it's not available. Okay? But if it is available from the start, then this check will not be true once, so we'll just go down to the bottom of the loop. And once the name is available, then we'll say this dot username equals name. Or we could just say username equals name. That's fine as well because there's no ambiguity. Okay? That's part A. And we used is available appropriately. You could have also done account.isAvailable. That's fine too. And in my opinion, I like to put the class name. I like to put this dot. But this is not within the scope of the AP subset. So you don't have to do that if you don't want to. And if this is confusing to you, that's just don't worry about it. Okay. All right. Part B. So now we're going to write the getShortenedName method, which, like I said, will remove all hyphens and the character before the hyphen. Okay. Now the good thing here is that, there's two things here. One, there's a post condition which says the username instance variable remains unchanged, and also that the username's length is at least 2. Okay, so we're guaranteed that there are at least 2 characters in the name, and that it does not start or end with a hyphen. Okay. Now, in my opinion, I actually think of this recursively. But I imagine that no one's going to solve this recursively, so let's write it using a standard for loop. Okay? So here's how I would think about it. What we're going to do is we're going to start off at index 0, and then go to the end of the string -1, and we're going to check 2 characters at a time, right? So if the current character is equal to, if the character after the one that we're looking at, the i+1th character, is equal to the hyphen, then we skip over both characters. Okay, so we're going to have an accumulator. We're going to have a variable that keeps track of the name that we're currently building. Okay, and it will, rather than stripping out characters from the instance variable, we're instead going to build a new string with the property that we care about, which is, of course, where all hyphens and the character before are removed. Okay, so I'll say new name equals the empty string, and then we'll just return it at the bottom. And also, as I'll show you in a minute, we have a test suite here that will just kind of run through the tests from the FRQ to make sure everything works. Okay, so this is not in the FRQ, by the way. This is just something that I set up just so we can make sure it works. Okay. So we create the accumulator, then we return it. This is a good way actually to get at least a couple points. If you have no idea what to do, you can declare a variable and then return it, and you'll probably get maybe 1 or 2 points. Okay, so just a helpful strategy maybe. Okay, so let's have our loop from I = 0 up to the length of the string -1. And we want to do that because we don't want to go up to the end of the string. We want to go 1 before it, so we still have access to the last character without going out of bounds. Okay, so I is less than this dot username dot length -1 i++. Now we're going to say if the i+1th character, if the next character is equal to the hyphen, then we're going to skip over this current character. We're not going to add this character. We're also not going to add the i+1th character. And I'll show you how I think of that. Okay, so if this .username.char@, now char@ is actually not in the AP subset, so you could use a substring i+1, and it would be the same thing. But I like char@ just because I think it's a little bit more intuitive. So this .username.char@ i+1 is equal to the hyphen, then we will do I++. Now, this is a little bit confusing, but hear me out. The reason why we do this is because let's say we have that string Amy, what was it again? Let's see, Amy Marie Lynn. Yeah, let's go with that. So, If we're on the Y, then the I+1th character is the hyphen. I hope you agree. So what we'll do is that I is currently 2 when we're here. So this I++ is going to move it to 3, and then the I++ in the loop counter will move it to 4. So we'll be on the M. Okay? So we skip over the current character, and we skip over the hyphen itself. Okay? So, if it's not though, then we'll just say new name plus equals this dot username dot charat of I. Okay? Very good. Okay. And then we just return it, and then we're done. So, let's run these test cases here. Let's see. Okay, so I need to, for the time being, we'll just make these compile. I forgot to do that. There we go. So let's see. Let's see. Expects this. Got that. AMAL. Okay. Yes. I forgot the one thing. Yes. Okay. So the problem here is that we also, because we are skipping over the last character, we always have to append the very last character to the string. Now think about why that is, and that's because this loop only goes up to the second to last character. We don't actually get to the last character. Now, because of this condition here, the username being greater than or equal to 2 characters, and that it doesn't end with a hyphen, then we can just always append that character. Okay, we can always append the very last character to the string, and it will always work as expected. We don't need to worry about like checking to see if it's a hyphen or not. Okay. So there we go. Very good. And just for the sake of checking, I suppose, let's create another account, and we'll just have it be 2 characters long. Let's say AA. That doesn't really matter. A5, and then it should expect AA as well, and it does. Okay. So by the precondition, we know that this won't occur. We know this won't occur. We know this won't occur. So we're perfectly good. Okay. So that's problem 1. Let's move on to problem 2. The bottle class, which you will write, represents a bottle that contains liquid. Bottle objects are created by calls to a constructor with a double parameter that represents the bottle's capacity in milliliters, which is the maximum amount of liquid in the bottle. Assume that this value will be greater than or equal to 0. When bottle objects are constructed, each is filled to its capacity. The bottle class contains an update amount method, which updates the amount of liquid in the bottle. This method has a double parameter that represents the amount of liquid in milliliters to be removed from the bottle, with a precondition that the parameter is always greater than 0 and less than or equal to the amount of liquid remaining in the bottle. If updating the amount of liquid in the bottle would cause it to be less than 25% of the capacity, the bottle is filled and reset to the capacity. The update amount method returns a double that represents the amount remaining in the bottle in milliliters after the amount has been updated. Okay? So it gives you a sequence of examples here, and then it says to write the entire class. Okay? So as we see here, we create a new instance of the class. It starts off with 1,000 milliliters, and then we withdraw 400, and there's 600 mLs remain in the bottle. We withdraw another 100, so there's 500. We withdraw 300, but then because there would be 200 left, that's less than 250, or that's less than 25% of the capacity. It refills, and then we return how much is left. Okay, so this is probably the easiest question on the whole FRQ. Okay, so I forgot to get rid of the solution. Let's get rid of that. Okay, so let's write the solution. So the first thing we need to do is think about, like, what does the question tell us to do, basically? Well, we know it has this update amount method, we know it has the constructor, and we know that it has a parameter to the constructor But we also need to think about what properties this class has. Well, we probably need a way of storing that capacity, right? So we're going to have a private double for, let's say, max capacity. And then we can also have a variable, maybe we'll use this, maybe we won't, but for current capacity. I actually don't think we need this. Yeah, let's keep it simple. So let's now write the constructor, okay? So public bottle. And then we'll say double capacity. It doesn't matter what the name is, as long as it receives a double, then we're good to go. So we're going to set the max capacity equal to capacity. Okay? So this sort of represents. Actually, so sorry, no. So we do need a an amount for current capacity. Okay? Or you can say like amount left over. It doesn't really matter. Let's do current amount, not current capacity. So we'll say current amount is equal to max capacity. You could also do just capacity here, it doesn't really matter. But this line is just following the prompt that says the current amount starts off as being completely full. Okay? So now let's do public double update amount. And then this receives a parameter called I don't know what it's called. It doesn't really matter. Just as a double parameter that represents the amount of liquid in ml to remove from the bottle. Okay. So what we'll do is we'll say this dot current amount minus equals amount. Okay. That's all we gotta do. Well, I mean, there's more to it, but this is sort of the bulk of it. At least this is the bulk of the logic. Okay. But now we need to check to see if this current amount is less than 25% of the capacity, then we need to refill the current amount needs to become the capacity again. We need to fill it up to the max. Okay? So if this dot current amount is strictly less than this dot max capacity times 0.25. Okay? Or you can say divided by 4, it doesn't really matter. Okay? If it's less than 25% of the maximum capacity, then the current amount is equal to the maximum capacity. And then it says, what does it say? It says we need to return however much remains in the bottle after the amount has been updated. Okay? So return this dot current amount. Okay? And truth be told, that's it. So let's run this file. I'm not sure why it's not finding this for me. Let's see, source, problem. Let's see. There we go. Okay. Okay. So let's see. So it says 600, 500, 1000, 1040, and I believe that is correct. Let's look at the 6, 5,000, 1040. Yep. Okay. So that's it. This is the whole problem too. Kind of surprising that something like this was on the AP exam, but that's okay. You know, I mean, the main thing with this question is reasoning about like what properties you need and how to work with like changing instance variables. You know, doing things like mutating an instance variable inside the class definition. Okay. So just, you know, again, you don't need the this dot anywhere if there's no ambiguity. Just, you know, make sure that there's no ambiguity. Like you can't do capacity here and then do capacity equals capacity. You can't do that. Okay? Okay. That's problem 2. Let's go to problem 3. The course record class is used to store information about a student enrolled in a course. A partial definition of the course record class is shown below. So here we see that it contains a student ID and then a number of absences associated with the course record. Okay? So pretty straightforward class definition. So let's keep going on. The attendance class maintains 2 array lists of course record objects named history list and math list. A partial definition of the attendance class is shown below. So here we see that the attendance class has a history list, which is an array list of course records, and a math list, which is also an array list of course records. Okay. So what we're going to do is we're going to write this method called more history than math absences, and it should return the number of students who are enrolled in both courses such that the student has more absences in the history course than the math course. So in this example here, we see that there is, there's OT32 and SQ98, which appears in both lists, and the number of absences in the history list for both of these two students is greater than the number of absences that they have in the math list. So for example, OT32 has 1 absence in the math list, but 2 in the history list, and SQ98 has 3 absences in the history list, but only 1 in the math list. Okay? It says there are 4 students who overlap. The intersection of the two is 4 students. But of those, only 2 of them have more absences in the history course than the math course, so the method returns 2. There's some nice prerequisites preconditions about this method. These array lists effectively act as sets, and what I mean by that is that there are no duplicates in the sets. There are no null elements, but there's a post condition in which the list must remain unchanged. Okay, so you can't mutate these lists. Okay, but this precondition is very nice. It allows us to reason about this in a way that would be a little bit trickier if we had to manage duplicates. Okay, so the way that I'm thinking about this is that we're going to have a loop that goes from the outer list and then into the inner list. So what we'll do is we'll say for every course record in the history list, we're going to then say for every record in the math list, every course record in the math list, if the student record or if the course record that we're looking at has the same ID as the math list record, the course record that we're looking at, and the number of absences for that record in the history list is greater than the one in the math list, then we increase some count. Okay? So we just loop over the outer list, and then we loop over the inner list, because if we loop over the outer list, then by definition the element must exist in the history list, right? Like if we're looping for every element, for every course record in the history list, then definitionally everything must be in the history list. Okay? So if we then check the math list and there is someone of the same ID there, then we know that they're in the same. We know that they're in both lists. So that's the first thing that we check, and then we just say if at the same time, if the number of absences for that record in the history list is greater than the number of absences for it in the math list, then we increase the counter. Okay? So let's think about this. Let's go to attendance, and let's see what we do. So first we're going to have a count, and then we can return the count. Pretty straightforward. And now we'll say for, so we can actually do this with an enhanced for loop. We can do this without an enhanced for loop. And to be honest, I would rather do this with an enhanced for loop, just because there's no need to have indices here, because all we're doing is just looping through the elements of both lists. The indices would only be used to index into the list. Okay, so let's say for every course record, we'll say CR1 in the, let's do history course record. For every history course record in the history list, then we'll say for every course record in the math list. So there's 2 checks. One, if the names are if the IDs are the same, and they have HCR absences greater than MCR's absences. Okay? So the first thing we check is that the IDs are the same. So how do we do that? Well, we go to the class and we see getStudentID, and then we can use getAbsences. So you have to use these methods correctly in order for this to work. So we'll say if HCR.getStudentID equals MCR.getStudentID. And remember, you have to use dot equals because you're working with strings and you have to use dot equals for comparing strings. Okay? So, if they're the same, and the number of absences is greater than mcr.getAbsences, then we'll say count plus plus. Okay? And then you can actually just break. You can either break or you can not break. It doesn't matter. And let's just not break. But the reason why the break is not necessary is because this check will only be true once. If it'll be true at most once because there's no duplicates. Okay. So let's run the main method here. So I created this thing here which is just so again, all of this is not in the FRQ document, and that's fine. But this is just a copy of the this stuff right here. Okay, and it says that this should return 2, and indeed it does return 2. Okay, so this one can be a little bit tricky if you're not careful with how you reasoned about this. And also, you may think, well, can I just do something like dot contains on one of the, like, on the inner list here? Can I just do, or can I just forego this entire loop here and just do like a dot contains check? And the answer is no, because that would be comparing course record objects, which you can't do. At least you can't with the AP subset, and you can't do with the information that you're given here. And also, that would mean that, yeah, if you found a match, that's good, but you don't know what the absences are for that match. So the two deep for loop here is basically the only way that you can do this. I think reasonably within the AP subset. So just be aware of that. Okay. So that's problem 3. Problem 3 was only one question. All right. Problem 4. The space class is used to represent the spaces on a game board. A partial definition of the space class is shown. So we see again, it's just a class where we have 2 properties, a color and a number of points. Okay. The GameBoard class maintains a 2-dimensional array of space objects that represent the game board. A partial definition of the class is shown below. So we're going to implement this method called getPointsForRow. So let's see how it works. When an element of the 2-dimensional array board is accessed, the first index is used to specify the row, and the second index is used to specify the column. So this is just like any standard 2-dimensional array problem that you've probably seen. So write the getPointsForRow method. The method should return the point value of the spaces in the row specified by the parameter target row. Let's see. Okay, yeah. So the point value of a row is determined as follows. If not all spaces in the row are the same color, the point value for the row is the sum of the points in the row. If all of them are of the same color, the point value for the row is 2 times the sum of the points in the row. So, for example, if we were to do call getPointsForRow 0 on this first row, it would return 1300 because not all of them are the same color. So it's just the sum of 500, 500, and then 300, which is 1300. Okay. If we did that for getPointsForRow 2, it would return 2000 because we have all of them are red. So we do 200, 300, 100, 200, 200, which is 1000 times 2, which is 2000. Okay. Now again, there are some nice preconditions here. So the board is at least 2 by 2, and that's important. Target row is always a valid index. None of the elements are null, and yeah. So this is some nice information that it gives us. So what we can do is we're going to say, okay, we know that there's at least one element in the row. Okay, so we're going to grab that. We're going to get the first element of the row, and we're going to store it in a. We're going to get its color, and we're going to store it in a variable. Okay, or rather, we can just get the space object itself. Okay, and so like for example, for cell 00, we're going to get the space object here, and then store that in some variable. Okay, and because of that, we will then start off a loop from I equals 1 down to the end of the list, or the end of the row, and check to see if all of the colors match that first space. Because if they all match the first space, then they definitionally all have the same color. Okay? So you don't need to check, like I imagine a lot of students are going to do something like checking to see if the current cell is the same color as the previous cell or something like that. You don't need to do that. With the preconditions that they give us, this is a very straightforward problem. Okay? So let's do that. Let's go to, we have the space class, we have the GameBoard class, so let's first get that space. So how do we get that? So we have the space class, and then we'll say first cell, that's equal to the board at the target row in column 0. Now we know that this column will always exist because of the precondition, right? We know that the board is at least 2 by 2, and the row must exist, so we're perfectly fine. But this will never be a problem. Okay. So now let's do the following. So we're going to do a loop from int I equals 1. I is less than the board at the target row. You could put 0 there, it doesn't matter. Dot length, and then I++. So basically we're going to iterate through the columns, okay? So in this case, if we go back to here, it'd be like we start off at this cell, and then we go to this cell, this cell, this cell, this cell. So row 0, column 0, or sorry, row 0, column 1, row 0, column 2, row 0, column 3, row 0, column 4. Okay? So that's pretty straightforward. I mean, I keep saying that, but it can be tricky to mess up. So if you did, don't feel too bad. This is not trivial. So now what we gotta do is we're gonna say if the current space that we're looking at is the same color as the first cell, then we're going to get the point value and we're gonna accumulate it in a variable. And speaking of that, we actually need a score counter, which we'll set equal to not 0, but the number of points from the first cell. Because if this were 0, then we would be omitting the score from the first cell, which we can't do. Okay? So we'll say if this dot board at target row of I, so the target row in the ith column, if the color of that is equal to the color of the first cell, then we'll say score. Actually, let me reread the problem. Let's see. Actually, no. Sorry. No, that's not right. I'm overcomplicating this. So we just need to do no. Oh, okay. So we do need this check, but the reason why we need this check is because we need to say all same color. We need a flag, a boolean, that will keep track of if they're all the same color. If we ever find a case where they're not the same color, then we're going to say all same color is equal to false. If we ever find one falsifying case, then the whole thing is false and it can never be true again. Okay? So if that's true, then we'll set that to false. But no matter what, we're going to say score plus equals this dot board at target row I dot get points. Okay? And then finally, we're going to have a case analysis that says if they're all the same color, then we're going to return score times 2. Otherwise, we're just going to return the normal score. And that's it. So I have the game board here set up from the problem. So let's run it and see what we get. So we get 1,300 for that first row, and then we get 2,000 for the third row. Okay? So that's it. That was the 2026 FRQs for APCSA. I hope this helped, and we'll see how everyone did in July. Thanks.